Introducing GXS. This is the first in a series of 6 videos about the Edwards GXS industrial vacuum pump. This series covers basic features, installation and operation, model selection, and typical controls. GXS is a range of dry screw pumps with vacuum pumping speeds from 160 up to 750 cubic meters per hour. And pumps can also be combined with integrated mechanical vacuum boosters with sizes up to 4,200 cubic meters per hour. The characteristics of the GXS can be described as fast, robust, intelligent, economical, and environmental, which together make it the ideal dry vacuum pump for all types of industrial vacuum processors. The GXS is compact, convenient, easy to install, and highly reliable. Dr. Simon Bruce will take us through the technical features.
So the GXS industrial dry vacuum pump we have here is a combination pump where you can see clearly we have the dry primary screw vacuum pump here, and in this case we have a combination with a Roots mechanical booster. So this is the screw pump. The inlet to the screw pump mechanism is through its inlet port here. There's clearly a spool piece which connects it to the outlet of the booster, and the outlet of the dry screw pump is underneath at the back at the low vacuum end. So this is the low vacuum end, this is the high vacuum end of the dry screw pump. Mechanical booster has its inlet at the top of the pump just here, and clearly pushes gas through into the dry pump behind it through the spool. The screw design is an innovative and patented screw technology which combines the aspects of variable pitch with a taper profile and the Quimby screw form. This gives this pump excellent dust and liquid handling. It can also handle 100% argon, and it gives the pump the low ultimate pressure capability, the low power consumption and low noise of this design. So now we'll just have a quick look at the electrical and electronic components of the GXS. 3 main things. First of all, there is the controller, or the brains of the pump. There is the inverter which drives the motor, which is over the back. Power for the GXS comes in through the standard Harting connector on the back and is distributed into the inverter. In this case, because we have a combination of a screw pump and a booster, we have 2 inverters because we have 2 motors. So power goes into the inverters. This DP dry pump inverter also supplies the low voltage, which feeds the controller. Now the controller provides the intelligence and the programming to run the GXS and do everything that it needs to do and provide all of the routines for operating the pump. The inverter of course runs the motors of the dry pump, the DP, or of the mechanical booster, the MB, and rotates the dry pump or booster at the correct speed. For the dry pump that's 110 Hz, for the booster that's 102 Hz. Because these inverters or variable frequency drives have the ability to have their speed infinitely varied, we can control the pumping performance of the GXS DP and the MB as well. The inverters also provide protection for the pumps to make sure they cannot be overloaded, and also protection for the motors as well. You can see here the motor for the mechanical booster, and over the back here the motor for the dry screw pump, the DP. The motors of the dry pump and the mechanical booster are high efficiency. They have built-in water cooling. They are hermetically sealed with the gearboxes of the dry pump or the mechanical booster. They share a common lubrication system. They are Intertek ETL listed and exceed the requirements of Euro IE2 standard. There are 2 versions of the inverters used on the GXS pumps. The so-called low voltage, which is this one here, and the high voltage, which is here. They're clearly distinguished by the colours. The orangey red colour of a high volts inverter means that this inverter is suitable for input voltages between 380 and 460 volts. The low voltage inverter with the Partia grey colour here is suitable for 200 to 230 volt inputs. Of course, both inverters are rated from 50 to 60 Hz, so it really doesn't matter what the supply frequency is. The GXS is fitted with a water cooling system which regulates the temperature of the screw pump, the DP, but also of the motor and of the inverter for efficiency. The entire water cooling system uses narrow bore tubing in stainless steel or composite material, which is switched on and off to maintain high flow rates through narrow volumes. So there is no requirement for any water jacket, with the consequent risks associated with large volumes of hot water, particularly through cast iron materials. So the dry screw pump, as you can see, is cooled here with these stainless steel tubing. The mechanical booster has cooling applied to the exit side, to the exhaust side here, and you can see the connections here. The motors have cast-in cooling coils. You could just about make them out there, and its connections there. The inverter has a back plate which is cast with water cooling coils, which you can see here. And all of the water cooling system is controlled with the black plastic manifold, which you can see right in the back of the pump over in the corner there. The GXS is fitted with various temperature sensors to enable the automatic temperature control system to function, and you can see some of them clearly here. This is the external temperature sensor of the mechanical booster, the MB. This is on the exhaust side of the booster, as it should be, and this gives the indication of the MB mechanical booster temperature. The dry screw pump has an external temperature sensor here, which is referred to as the TCS reference, temperature control system reference. It's the external body temperature, but there is a computed internal screw temperature, which is actually the DP temperature reported. And of course the motors and the inverters also have internal temperature sensors which enable the temperatures to be monitored and controlled.
There are 3 different levels of application purging available on GXS: light duty LD, medium duty MD and MD+. For very clean applications, LD is suitable, but for most typical industrial applications, MD is recommended, as this includes gas ballast, inlet purging on shutdown, and an exhaust pressure sensor. For the dirtiest of applications, MD+ would be recommended, and this is covered in video 5.
As standard with the light duty, we have here at the high vacuum end the high vacuum purge, which protects the bearings and seals with a small flow of purge gas here. And at the low vacuum end there is the SSP, the shaft seal purge, which you can just make out there, which protects the low vacuum end. Now when we go to the MD medium duty version, 3 things are added. First of all, there is the inlet purge system, which is purging through here, normally used during shutdown of the pump to provide clean nitrogen to flush the pump through as it's shutting down. That connects in here. Then as we go close into here, you can also see that there are gas ballast connections here. Because this is a larger pump, a GXS 450, we have 2 gas ballast connections here, gas ballast 1 and gas ballast 2 side by side. Just getting back here, that's of course the shaft seal purge, which is fitted to all pumps. And then there's the exhaust pressure sensor system, which you can see here, which connects through to the exhaust side of the pump and enables the pump to know the exhaust pressure and check for any blockages in the exhaust. All of the purging on the GXS is handled and controlled by the purge gas manifold block, which you can see clearly here, and all of its connections through to the different ports to feed the purge gas through. On this GXS 450 screw pump, you can see there are the 2 controls for the gas ballast. Gas ballast 1 has a manual needle valve, gas ballast 2 has a solenoid valve which can be commanded to be open or closed. And of interest there, here is the line which goes through to the exhaust port, so that the exhaust pressure sensor shown here actually senses the exhaust pressure, and there's a very small flow of gas going through it to keep this line clear.
There is a range of optional accessories available, and several of these are shown fitted here. They include inlet filters, inlet isolation valves, adapter spools and exhaust silencer traps. The use of suitable purging level and suitable accessories means that the GXS can be applied to any type of industrial vacuum application, from drying to coating, from automotive to metallurgy, from polymers to aerospace. Let's look at connecting up and starting the GXS.
All of the utility connections are found on the back of the GXS pump. The power goes in through the Harting connector here. Cooling water goes in here and out of here. The purge gas is connected to the bottom of the flow meter here. Here is an RF safety earth, and the exhaust to the pump on this version is here. There is also a version of the GXS where you can have the exhaust at the side. Electrical connections are here. Here is the Ethernet port, the serial port. This D connector is for optional accessories. This socket here is for the optional MCM microtim. That's for remote hardwired control. And here is the all-important emergency stop system plug. Every GXS is fitted as standard with the dashboard, which is a very simple method of controlling the pump, running it, starting and stopping. There are 3 simple buttons: a button to take control, a button to start the pump, and a button to stop the pump. There is also a red emergency stop button here. So, to run this pump now, very simply, we take control by pressing the control button, and the green LED comes on here, so we have control, and we press the start button here, and the pump starts up according to the programming.